Hi there, my name's Brett and this video is about home improvements for energy efficiency and thermal comfort. I've done my home improvements in 3 stages. Number 1, seal it up. Number 2, install underfloor insulation. And number 3, top up my ceiling insulation. I live in Melbourne, Australia, which has a cool, temperate climate. This house was built in 2016 to a 6-star NAITHS rating out of 10. It has double glazed windows and a modest level of wall and ceiling insulation. We definitely notice the cold winter mornings and need for significant heating and cooling throughout the year. In Australia, homes built before 2016 average just 1.5 to 3 stars out of 10, which means they need around 3 times the energy to heat and cool the same space. So I've gone all out for this video and bought a FLIR thermal imaging camera. This plugs into the bottom of my smartphone and will help me find the cold spots around the home. The biggest benefit you can make to your home is to seal it up, to stop the outside air from getting in. The front door is usually the biggest culprit. Around 30% of your home's heat can be lost around the door edges. If you hold your hand against a door on a cold night when your home is heated and you feel a cold draft, then it's worthwhile sealing up. A draft stop for below your door is the best place to start. My one is no longer fitting, leaving a large gap for air to get in underneath. Next, do the top and side of your door with a weather strip. A weather strip is a spongy strip that allows a door or window to sit flush against a surface, thereby filling any gaps and stopping air from drifting in and out. Indoor air quality is important for your health. Once you have sealed up your home, you can now control when to flood your house with fresh outside air. My next task is an obvious one for this house, one that I can feel when I wake up on a winter morning. It's the cold floors. This house has no underfloor insulation. Look for the insulation material and R value when buying insulation. The R value is a measure of the insulation's resistance to heat. The higher the R value, the better the insulation. I've gone with R 2.5 for my underfloor. I've bought 90 square meters of polyester insulation called Greenstuf. Polyester is safe and non-toxic, so I don't have to wear special protective clothes nor dust masks when installing. Greenstuf is also made from recycled plastics, and it is lightweight and can be stapled into the joists underneath the home, making it my clear choice. For materials, you will need a tarp to keep off dirt and dust, a staple gun and a few thousand staples, or one for every 20 centimeters, a broom, a measuring tape, and your Greenstuf insulation. When you're under the house and you're on your 3rd change of clothes, open your insulation up and give it time to decompress, about an hour or 2. Second important step is to remove those cobwebs and watch out for spiders. Greenstuf is very easy to handle, and you can just tear its insulation roll where required. It took me about an hour and a half per 15 square meters. So all up, I did my whole floor space across 3 weekend days. Other insulation materials to buy on the market include Earthwool, Rockwool, and Glasswool. Earthwool is a close second choice of mine, as it is also safe to use and does not contain any toxic elements. Rockwool and Glasswool are better than nothing, but probably come last on my list. Both materials will irritate your skin and eyes, and breathing in those fibres may be hazardous to your health. If using, be sure to use a dust mask and avoid skin contact. Once installed and left undisturbed, these materials are fine to leave. Staples should be every 5 centimeters at the ends and every 20 centimeters in between. I'll save you from the next 2,000 staples and skip ahead. Look out for holes in your floor, such as this one underneath the bathtub. So what I'm doing here, I'm just filling these blatant holes with some foam board that I've cut, albeit not that sharply, but it's a nice fit, and with a bit of HVAC tape, it'll create an airtight seal. Make sure you do the whole underfloor, as gaps can decrease the effectiveness of the insulation by up to 1/3. Be careful to weave the insulation, or do bit by bit around pipes, and turn off electricity at the main switch if wires are around. Now, bits that you've skipped over, such as this shortened joist, can be filled out at the very end with the offcuts left over. Next is our ceiling insulation, and recessed downlights can be a main culprit here for heat leaks, since insulation must be installed at least 20 centimeters away from the lights to prevent overheating and possibly ceiling fires. Newer downlights don't have this same requirement, but that's not the case for this home. This is our lounge room with the thermal imaging camera. If we have a look at the downlights in the ceiling, we see cold gaps where the insulation is missing. This is the hallway to our front door. We can see the cold edge. Let's have a look at the lights, and again the same gaps in insulation. You can even diagnose when someone sits on a toilet and see the cold around the toilet in contrast. This is the other type of insulation for the ceiling. These are recessed downlight covers to separate the electrical wires from the insulation, and that's all going up here. Is there going to be a way to get this insulation up the ladder and into my crawl space? Probably not. So I'm going to just cut it. They say these things are compression packed, and you can see just exactly how compressed they are. If you're wondering why the thermal camera picked up large cold spots where the hot air escapes, once you're up in the ceiling, it becomes crystal clear. The reason is that the NAITH's building rating is done at design stage, which means there is no verification of the quality of job actually done. Gaps in insulation can reduce the performance of insulation by around 1/3, which is exactly why we are filling these gaps today. This is a Rockwool from when this place was built in 2016. It covers most, but not all, of my ceiling space. It's quite itchy and unpleasant, so I recommend covering all your skin and using gloves. We're also in a confined space, and this has small breakaway fibres, so a P2 dust mask is also important. You can see the difference between the two. That's Rockwool, and that's the Earthwool I've just brought up into the attic. Earthwool, 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 Rockwool. Made it down the other end. Got my light covers. Some more right covers. And my Earthwool. So I wish this demo was a little more space to show you around, but it's not. That's my light. These are my cones. I'll do a bit of a time lapse. Take 2, black wire goes in hole. The other top up I'm here to do is just gaps in the ceiling insulation for no reason. Number one, move it. Number two, fill it. This is by far my prettiest light that I've done. The light box and wires all sit above the cone. The insulation abuts around the cone. It'll be good to see the results on the thermal camera on this one. What's useful to fill around the last small gaps is just little squares and even ripping apart the layers and just stuffing it in between. Another one bites the dust. Once you've filled up your gaps, place any excess ceiling insulation straight on top of existing insulation to make it twice as effective. If your existing ceiling insulation is old and worn down, you can choose either to replace it directly or just top it up. Back to the living room. We've done the ceiling now. You might have just been watching TV. What does my roof look like? Look at that, no gaps in the insulation. That was actually a very difficult light to access, so maybe couldn't quite cover that one. There we have it, home improvement done. And I gotta say, this place does feel warmer. Post any questions and comments you have below, and thank you for watching.